In this video, we're going to talk about nuclear fission. Unstable radioactive nuclei, which occur naturally, sometimes emit strong radiations, especially in isotopes of uranium like uranium-238 or uranium-235. The disintegration converts the uranium isotope into stable lead and in the process emits energy in the range of 1 to 5 mega-electron volts. That's 1 to 5 million electron volts, and even higher amounts of energy can be released by breaking unstable nuclei into even more parts. In 1939, a German scientist named Otto Hahn discovered that breaking up the nucleus of uranium-235 into two parts emits 200 million times the energy of the neutron which triggered it. He, along with his two colleagues, Lisa Meitner and Fritz Strassmann, found that when the nucleus of uranium-235 is bombarded with neutrons, it will absorb one of the neutrons. This results in an unstable compound nucleus, and the nucleus breaks into two equal parts. This process is referred to as nuclear fission. So, a process in which heavy nuclei are bombarded with neutrons and split into two equal masses, releasing enormous amounts of energy, is called nuclear fission. In the process, uranium-235 initially absorbs a slow-moving neutron, thus forming a highly unstable compound nucleus, uranium-236. This is what triggers the nuclear reaction. During the process of fission, uranium-236 splits into two product nuclei, which are barium-141 and krypton-92. You should notice that a barium atom has 56 protons and a krypton atom has 36 protons, which add up to the uranium atom's 92 protons. The unstable uranium-236 nucleus also releases 3 neutrons in the process. This happens because barium-141 has 141 neutrons and krypton-92 has 92 neutrons, adding up to a total of 233 neutrons. To balance the equation, uranium-236 must emit 3 more neutrons. The chemical equation of the nuclear fission reaction taking place can be represented by this equation. So as you can see from the equation, 1 neutron combines with uranium-235, forming an unstable compound nucleus, uranium-236. This unstable nucleus splits into 2 stable nuclei, barium-141 and krypton-92. In addition to these 2 nuclei, 3 neutrons are also emitted, as well as a high amount of energy, denoted in the equation by Q. Since uranium-236 emits 3 neutrons in the reaction, these neutrons can be absorbed by other uranium-235 nuclei, resulting in a chain reaction. This leads to exponentially high amounts of energy being released by a single reaction. So, in this video, we've covered that nuclear fission reactions result in massive amounts of energy being released. Now, these nuclear reactions are most well known for the part they play in nuclear bombs, but they are also an essential part of nuclear reactors, which have the capability to provide mass amounts of energy with relatively low cost. But that's a different topic altogether.